session of Perspectives, the Open Lecture Series. Good afternoon, ma'am. So, the idea behind Perspectives is that there are 3 courses here. We are Public Policy and Governance, Rural Development and Governance, and Development Studies. So, over the course of our 2 years here, we do a wide range of courses, right from quantitative analysis to ethical theory. So, as part of this, we come across diverse viewpoints, especially in terms of theory and in terms of how it's practiced in your life. So, the idea of Perspectives is that we call permanent development practitioners, policy analysts, policy makers, people in the political arena, social arena to come and give us their perspective. So, eventually it helps us take a stand and we learn more from different viewpoints. So, over to Pankaj sir, who is going to be chairing the lecture today. Sir, please.
So, good afternoon. Let me formally first introduce Swati to you. We've all seen her introduction, we've circulated that, but I'll still read it out. Swati is an environmental design consultant with over 13 years of experience in environment building, design, computational analysis and assessment, and environmental policy research. She is a founding partner and director of Terra Viridis, an environmental design consultancy which is based in Hyderabad, that she started 7 years ago. She works extensively with the government but also with the private sector, and she would just say very interesting work happening in the private sector. They work directly with large industrial houses and large institutions like Infosys. They work with the Manipal group of campuses, hospitals. And before this, she worked at the BDSP Partnership, a sustainable design and engineering consultancy in London for 6 years. When she was there, she worked with a number of international architects such as the Richard Rogers Partnership, Foster and Renzo Piano. Of course, these are only names to us, so maybe you can tell us a little bit more about them. I'm sure there's interesting stuff about it, briefly, maybe. On a number of projects, including in Abu Dhabi and the British Antarctic Research Station. Importantly, she is a strong proponent of passive design as the first step towards sustainable design, constantly applying learning from local vernacular to new buildings, I think, which is a very interesting area. The firm that she initiated works extensively with computer-based building analysis to help architects make design decisions. And she's also associated with Griha, of which she's a founding member, which is a kind of a rating agency for environmental design and stuff like that. And also, let me, at a very personal note, let me also introduce Swati as a friend. And the friendship comes through our children. She has a 4-year-old daughter and I have a 4-year-old son, and they are in the same class. So we got to know each other because of our children and not any other reason. And then of course we got talking, and just found, I've known her for 2 years and not had much chance to actually speak to her, but the little conversations we've had have been very fascinating for some of the things that her bio talks to us about. And when we in the faculty were discussing whom to invite, when Swati's name came up, we were very excited because of her background, but also particularly the policy area concentration of urbanization, and of course the other things as well. So, Swati, welcome. Thank you very much for accepting the invitation and really looking forward. Thank you so much.
Thanks for inviting me. Thanks for inviting me, and I hope I stand up to your expectations with my presentation. I just wanted today, well, some of the things, just to give you a little background, the names that he spoke about are probably some of the prominent buildings that you see around, like the Gherkin in London, and those are the kind of projects that we had worked on, which are all green high-rise buildings, different types of green buildings across the world, both in Europe, US, Abu Dhabi, Middle East, India. So I have been primarily working in India and Malaysia for the past 7 years since I started my company here. Today I would like to talk about, I've been working with the policy, at a policy level with the Hyderabad Metropolitan Development Authority for a while. We developed the environmental building initiative for the city of Hyderabad way back in 2007 until 2010. And then it's been taking a very long time for it to slowly come into the public realm, and having that being introduced into the policy is taking a little bit of time, as usual with the government, and especially with the kind of unstable governments we have been having in Andhra recently. But we've been working with HMDA, and we've also been working with the Ministry of New and Renewable Energy through Griha, which is a green building rating system for buildings in India. From that background and from that perspective, I of course work a lot with the private sector as well, such as the Infosys campuses like the Manipal group, the Institute of Public Enterprise, some of the hospitals, some hotels around the country. From those perspectives of working with at the government level and also at the private sector level, I'd just like to give you my perspective on green buildings, why it is important at a larger scale or at a macro scale to introduce stronger policies to promote them. Green buildings, I understand, there's a lot of greenwash happening. Can everyone hear me? Is that okay, or do I need to use the mic? Yeah, I do. So, before I start, I would like to sort of clarify one point about the so-called green buildings that you hear about around a lot nowadays, and personally, I don't like use the word green. Because there's so much greenwash happening, just about anything and everything is named green nowadays. Even a tree planting drive without doing anything else in the world is called green. Right? So that's why personally I'd like to call it sustainable building design or high performance building design rather than a green building design. So having said that, I'm just going to go, I don't want to keep looking at the screen, so I have my laptop here. See, the choice is that, we all know that India is going to urbanize very, very fast in the next few years, and there are several reports, I'm sure you've studied about it, and there are so many reports ranging from what Terry has come up, or McKinsey has come up, or any other consultancy firm has come up, that India is going to urbanize massively, but I'm just going to put the context across from some of these reports. But what I'd like to mention is that the choices that India makes to manage the process of urbanization is very much for India. It has consequences for the people and for our economic future of our country. But the approach Indian policymakers will take is not just going to affect us, but globally. So just purely because of our population and the kind of urbanization we're going to see in the next few years. I'm sure a lot of you are familiar with these numbers. A lot of you are familiar with these numbers that I'm going to show in the first few slides, that 40% of India's total population is going to be urbanized by 2030, which is probably something like 25% right now. And the scale at which we are going to urbanize, the speed and the scale at which we are going to urbanize is going to be China and nothing else in the world. And urbanization will spread across India. I'm sure a lot of you know these things, but we know that it's going to spread across everywhere in India, and there will be 5 large states, Tamil Nadu, Gujarat, Maharashtra, Karnataka and Punjab, where there will be more urbanized population than urban population than rural population by 2030, and these are the projections. A few more numbers, we will have twice the population of USA living in cities in India by 2030. 70% of new employment will come from urban areas, and 700 to 900 million square meters of commercial and retail space and residential space is going to be big, needs to be built. That is, if you want to put that into perspective, we need to build a new Chicago every year. So that's the kind of development that is going to happen in India. Even with the growth, slowing of our growth, we see that it is a temporary slowdown, but the growth is going to happen. Coming back to urbanization, 68 cities will have population of more than 1 million by 2030. More than 1,000 rural villages will be converted into urban areas by 2030. Comparing that to, Europe, which only has about 32 right now. Just also put into perspective, because I worked in Europe extensively. For them, our villages have 100,000 population, and for them they can't even think of that as a village. They think 100,000 population is a city for them. So they can't even imagine. And some of the campuses, like the Infosys campus, which has, some of them are being designed for about 90,000 people. And lot of businesses, campuses, or educational institutions, for that matter, are being designed for 25,000 people, 30,000 students. So these are numbers that anywhere outside India and outside China, people just can't handle. They think that these are unbelievable numbers that they just can't understand where all these people are coming from, that we know. But the way I want to bring it down to the impact buildings are going to have by 2030. This is what urbanization would mean, and what increase in built-up area would mean is increase in greenhouse gas emissions across various sectors. But if you look at this graph, this is 2005, this is 2020, and this is 2030. By 2030, the largest chunk of greenhouse gas emissions are going to come from buildings, compared to any other sector. Not just that, that is just greenhouse gas emissions we're talking about from energy consumption in buildings. We also are going to have several challenges with our water supply, with sewage, with solid waste, with the number of cars, with public transport, and with housing. So it's going to be we need about 2.5 times more water. But where is that going to come from? Right? If we just have to keep expanding like this. Of course, there will be a similar amount of increase in sewage generation. So unless we try and manage these sewage generation and water properly, where are we heading towards? We're also already seeing so much pollution around. We're already seeing so many issues related to water in India. We don't have enough drinking water. We have flooding issues. So we don't know how all our lakes and rivers, everything is getting polluted quite badly. So unless we learn to manage these things very sustainably in a very efficient manner, the growth that we are perceiving that will happen will not happen. And even if it does, our quality of life is going to be so poor and so bad that a lot of people it's not going to be livable anymore. So that's why we've got, we have solid waste. Look at the amount of solid waste that is going to be generated. It's predicted that the solid waste will increase by 5 times. So right now we might have a few, I'm not saying we do not have any policies to deal with these issues, but our policies are not enough and our implementation structures are definitely highly lacking behind. But most importantly, this is a graph that I have been using for a lot of presentations for several years now, but I find this an extremely useful graph to show you. It's from Harvard Business School. Is that the competitive index of any country is directly related to the environmental regulatory index or regime index, which means the better environmental regulations in a country, the more competitive it is. And this has been proven across. So if you see the countries which have the best environmental regulatory index, like Finland, Sweden, Switzerland and Netherlands, are also the most competitive. We are right now somewhere here. Our regulatory index is pretty low, environmental regulatory index, and there's not much happening to improve it either, and that's my major concern. But as you can see, the better the environmental regulatory index, there's a direct correlation because it improves your quality of life, which means that when it improves your quality of life, you have more reliability on the resources, and it attracts the right kind of people, the right kind of talent into that country, which definitely relates to the growth of that country in a positive direction. It's as simple as that. I'm sure, again, a lot of you know about this, the 5 dimensions important to urban development. The dimension that I would like to concentrate on today is environmental sustainability. Specific sector policies relating to environmental sustainability. And coming back to buildings, 80% of India in 2030, and that you see in 2030 is still to be built. So we are not talking about policies for existing buildings as much as we are talking about policies for new buildings. And why is it important? Is because of this particular number. And another thing that is very important is, another thing I would like to bring buildings into perspective as to why buildings are so important when we talk about energy related policy or resource related policy or waste related policy, is because of this. The potential to reduce power demand through energy efficiency in a building. Not supply, mind you, this is just demand management, just by reducing the demand in buildings. Buildings have the highest capability. So what it says is, from 2005 to 2030, the power demand is going to increase by 4.5 times. And we have the potential to reduce this, or there is an abatement case about 25% in this. Of this 25%, the largest chunk again comes from buildings. Largest chunk comes from efficiency in buildings. So this, again, I would think is a very conservative estimate compared to what the private sector is doing right now. So 390, as you can see, is the largest chunk, or this is the largest. This is the most one of the. This is the what I'm trying. This is the most effective way of reducing our energy demand by 2030. This again is dependent only on a few factors, by changing, LED lights, by making more efficient or introducing more efficient appliances, and by improving the HVAC efficiency or the cooling loads or cooling efficiency of a building. But if you actually look around and see all the various efficiency measures that the technology that is available right now can provide us, this can easily be tripled, very easily be tripled over the next 20 years. So before I go into what is happening in present day India and the kind of efficiencies that the private sector is achieving right now, I want to just quickly go through a history of green buildings or sustainable building design in India. And this is where my interest in vernacular design comes in. So we, as a country, have been doing sustainable design for thousands of years. I mean, literally thousands of years. For example, look at our temple complexes. Back then, there was no energy. There was limited. People couldn't bring water from 250 kilometers away. They couldn't pump water from so far away. So they had to manage with the resources that they had within their regions. So because of this, the purpose of any building throughout the history of mankind was to be comfortable. And they managed to make buildings comfortable with no use of energy, be it visual or be it thermal. So if you go to any very old temple complexes, be say Chidambaram or Tanjore or any of the really old temple complexes, even if it is 42 degrees outside, inside that building you will have a cool breeze. You can actually have a nice nap because it is very cool, it is very comfortable inside, and there is enough adequate daylight constantly. Any season. If you go in winter, it will be warmer inside than it is outside. It's just a constant temperature that is maintained passively without the use of any artificial cooling systems. Similarly, water was naturally collected in the ponds. Waste was managed traditionally. As a society, we have never been wasteful. We always recycled and reused till the point of no return. That's how we have always been brought up, and that's our culture, our innate culture. And they were all highly functional. These buildings were used for 5 different purposes, and they had a low embodied energy because they used materials from local places, local materials, and they were lasting. They lasted for 1,000 years. These buildings are still standing. Can you say the same about any of our new buildings? Do you think they'll stand after 50 years? Forget 100 years. any of the new constructions won't stand for more than, real sustainability back then. Even 500 years ago, the palaces and forts were still quite sustainable. They made sure that people who are living inside were comfortable, they had the right kind of designs, they used courtyards, they used jalis, they used verandas. So they used different kind of shading techniques and daylighting, diffuse daylighting techniques. They used evaporative cooling techniques to keep their buildings cool. If you go to Agra Fort, they have water flowing within the walls to keep the building cool. It's a concept called radiant cooling that is being revived right now. So all these buildings were so comfortable and they were all using zero energy. So they're all actually zero energy, zero carbon emitting buildings. Even 100 years ago, our colonial buildings were not too bad. They still used all the principles of architecture, all the principles of passive design. So they all used the principles of vernacular design to make comfortable buildings with very least amount of energy usage. I won't go into all these technical details, but I will leave it with you if you want, if you're interested. And then even 40 years ago, vernacular architecture was not too bad. The older architects, even to this day in India, like Charles Correa or B.B. Doshi, they all use vernacular design principles, or Jeffrey Bava in Sri Lanka, or Laurie Baker in Kerala. They were all using very traditional vernacular design principles to make buildings comfortable with the least amount of energy. So, and then only the last 10 years, with the globalization, with the abundant availability of electricity, people have forgotten about it. They've suddenly moved from our 1,000-year heritage to a high energy consuming, a very, very high energy consuming building architectural syndrome, I would say. We are not, so some of these buildings, if there is a power cut, there is no way you can survive in them. You are almost really cooked, it's like an oven. And because they have no, so because they have, even when the temperatures outside are 40, 45, the indoor temperatures cannot go up to 50, 60 without air conditioning. And because they don't have any kind of shading outside, they have to pull down their blinds and turn on their artificial lighting. So the whole concept of using a lot of glass, getting away from traditional or vernacular design principles has led to a very high energy consuming buildings over the last few years. Also with us being able to pump in water from 250 kilometers away from Krishna and Godavari, no one cares about water anymore. And the waste that is collected from our houses, how many of you have ever followed that waste and see what happens to it? We don't know. Do we know that it is getting recycled? If it is getting recycled, how is it getting recycled? In what are the conditions that it is getting recycled? How much of it is getting recycled? We don't know. All we know that it goes into a landfill somewhere. And 85% of it actually goes into the landfill. Only about 15% of it gets recycled. And that too in a very inhuman way by children, rag pickers with no shoes, no protective gear, who go around rummaging around all the rubbish and pulling out what is important. So that's the situation, and that is what modern architecture has led to. And modern urban design or urban planning has resulted in. People are taking away the problem from your houses and dumping it somewhere else. Or they're bringing in, they're trying to solve your problems by taking resources from very, very far away. But however, in the last few years, I would say less than 3 or 4 years, or maybe 5 years at the most, there has been a trend towards little more efficient, more responsible building design. So there has been some policy initiatives in our country for this towards low energy or low energy building design or low impact building design. But we still have a very, very long way to get there, to complete our cycle and go back to what we were 1,000 years ago. So we still, because we forgot a lot of things that we learned over thousands of years in a very, very short period of time. We forgot everything that we learned. So even if I go back to my school of architecture and my architectural training, the amount of importance that is actually given to vernacular architecture or low energy architecture is so little that probably in our class of 60, only 2 people took it seriously. No one else cared about it. So you can see even the education of architecture is not in the right direction anymore. So whatever we have learned over, we know all our 1,000 years of knowledge that has passed down from generation to generation to generation has suddenly been lost over the last 10 years, which is quite sad. But I'm hoping that it's nothing's lost, it's not as if there's no hope. There is still hope because there's a lot of there's a positive movement towards low energy architecture and low energy buildings or low impact buildings. There has been a big movement over the last 2-3 years, especially from the private sector. There has been some policy initiatives from the central government, from the government as well, but probably not as much. So from here I would like to just go and show you that there are, what is possible with the technology that we have got right now? What is it that is possible in today's world? With the technology that we have available in India without increasing your cost. So all the multinationals, I'm saying almost every single multinational out there, be it Microsoft, be it Infosys, be it Wipro, be it IBM, be it any multinational, they have realized the risk of the future that they see in the future, the risk of lack of resources that they see, that will have a direct impact on their productivity, on their business. So that's why they've started already building smart cities and smart campuses. So when I'm talking about smart campuses, I'm talking about campuses that range from 15,000 employees to 140,000 employees. So these are the size of campuses that these guys are building, and they are building it in such a way that they mitigate the risk that they see for the future, that they see in the future. So I'm just going to show you some examples of work. One is a university campus in Jaipur. Presently, it is a university campus for about 6,000 students, but sure, soon it has been planned. It is going to be expanded to meet. It's going to accommodate about 25,000 students in the next 5 years, and that is the present. That is the overall plan of this university. So, what did they manage to achieve in this university? Through very low-tech measures. There's nothing high-tech in what they have used. There's nothing out of the world. There's nothing really new here that they have used to achieve the kind of results they have achieved. So they have managed to reduce their energy consumption by more than 60%. So usually our energy benchmark for a campus like this is around 80 kilowatt hours per square meter per annum. That is 80 units of power will be used by that by that building per square meter per annum. And that has been brought down to 30. And no, there hasn't, it's not rocket science at all. Water use has been reduced to 25 liters from 45 liters per person per day. In fact, this is just the water demand reduction. Their overall water use, I'll come to it, is even lesser. And they are using 100% of their waste is being recycled on site, and the rest of non-recyclable waste is being recycled outside their site. And they have, in a place like Jaipur, they have planted close to 20,000 trees without a great pressure on the water, and all this they managed to do at a cost lesser than a typical CPWD building. So if a typical CPWD building is 3,500 rupees per square foot, and the MUJ buildings cost 2,500 rupees a square foot. and they have all those performance benchmarks. So they're managing to meet all those performance benchmarks, and every new building is planned to be better than their first building. And those are the statistics I showed from the first building. And let me just show you, I'm just going into a little more detail, so probably not as relevant, but this is how they managed to achieve it. Number one, through building design. You know, how do you use all the vernacular design principles that you see in Jaipur, in a hot and dry climate like Jaipur. You use the vernacular design principles first, reduce or optimize your building design, reduce the amount of heat that is coming into your building, maximize the amount of daylight, diffuse daylight that is coming into your building. When I mean daylight, usable daylight, not just daylight. Daylight without direct sun, diffuse daylight, that is what is usable daylight. So, they first look at the building design, then look at the systems, make the systems as efficient as possible. So once you have this, your system sizing goes down by close to 45%. Once you get your building design right, your system sizing goes down. Your system sizing goes down by 40 to 45%. And you actually start saving your money on the reduced system size. And that extra system size and that extra money you can spend on making it more efficient. So that's what's happened. And then look at alternative renewable energy sources, which would mean going in for solar or wind or whatever. How did they arrive at these? So these are different ways that they managed to come across, or different ways that they started. So they used a lot of very well-shaded corridors. They used the traditional jali systems to cut down the amount of light, cut down the amount of heat, and bring in cooler air. Just to give you a quick understanding of how jali works. So if you blow air on your hand like this, it's warm. Can you try it out? Right? And now just close your mouth or make it very small and blow it out like this. It's much cooler. It's Boyle's law. Same amount of air going through a smaller opening, it reduces the temperature of that air, and that's how jalis work. And that's why jalis are not only good for cutting down the amount of direct sun and solar radiation coming into a building, it also cools down the wind that comes into the building. So that's the principles behind jalis. So they used a lot of course, not just that, they used a lot of, we did a lot of daylight enhancing measures. We ensured that all the classrooms could be used without the use of any artificial lighting during the day through at least 80% of the year. So we ensured that there was enough that it could be used. The building, in spite of it being in Jaipur, could be used without any air conditioning for at least 5 months a year. So all these things were taken into consideration. And after that, we started looking at what are the various types of systems that can be introduced to reduce the energy use further, like LED lighting. So all the lighting out there was LED lighting. And the system, because we managed to save money by reducing the system requirement, we had that extra money to spend on all these extra features, like lighting, like LED lighting, like a hybrid HVAC system with evaporative cooling. So what it has resulted in is that when I look at what we simulate or predict the energy efficiency of a building to be and compare it to what has been achieved on site, it has been consistently lower. So the blue is what has been predicted through computer simulations, annual computer simulations, saying that this is what the energy performance would be per month, and this is what has been achieved. So there are two blocks, and this is the kind of, over the last 1 year, this is the kind of energy use that they have been seeing. So which is sometimes as low as 50% to what has been predicted before. Because people are adapting to slightly higher temperatures. For example, you would think that we cannot live in temperatures more than 26 degrees or 25 degrees. You would think that we need air conditioning if it goes beyond 26 degrees. But if you make your building comfortable, if you have enough buffer spaces, like in this place, even at 30 degrees, no one is turning on their air conditioning. So even, and there are several, like the National Building Code says that you need at least 300 lux of lighting to be comfortable to be able to read. But in this place, you don't have more than 100 lux sometimes, and even then they don't turn on their artificial lighting. Because it is sufficient, right? So a lot of these codes are also over-designed to a certain extent, and they expect. So and they are also taken from different other countries, and research hasn't gone into them for the last 40-50 years. So we are using 30-40-year-old codes to this day without improving them any further. Not just that, if I look at the kind of water reuse systems that has gone into this campus, there is harvested rainwater that is used. There is treated water from the building that is reused for flushing in the building. There is treated water that is used from the hostels. There is excess treated water from the hostels that are used in this building. And by doing all this, the amount of fresh water requirement has gone down to 16% of the total building requirement. So this is what is achievable with what we have right now. So and also it had, being Jaipur being a very drought-ridden area, it had quite a good drainage systems. They used very efficient systems like drip irrigation systems and sprinkler systems. The kind of trees that they use or plants that they use were all native plants which used very little water. So this is how they managed to increase their green cover by not increasing their water usage by too much. And all this at a cost much lesser than the CBWD cost. And this is nothing high-tech here. There's nothing new here. All we are being is we are being prudent. We are being very miserly, like all Indians are, right? We have always been miserly about our resource use, which has brought us this far. That's why we have lasted this long, and the other countries haven't in their resource uses. The other example that I want to show you is Infosys. Please stop me anywhere if you have any questions or if you. And Pankaj, please let me know if I'm going into too much technical detail, which I don't know how much. So, I'm going to go into, that was a very low-tech campus. It was not a high-tech campus, a very low-tech campus. Now I'm going into a high-tech IT company building, an Infosys building, which is, probably the most energy-intensive industry, apart from the manufacturing industry, it's energy-intensive, people-based industry. So all Infosys buildings are around 3.5 lakh square feet. Every single Infosys building is around 3.5 lakh square feet. They have about 3,000 to 3,500 people in each building. And this is what they have managed to achieve again with high technology. To me, these are 100% air-conditioned buildings. So we are able to achieve these kind of energy savings without compromising on our comfort even a little bit. Because these guys, believe it or not, once they enter the campus, they want to be absolutely comfortable. They don't want to take any bit of discomfort in their daily lives, not even for a second. So they have to be kept comfortable, otherwise there are complaints pouring into the facilities team every minute saying that, oh, I'm having a headache, I'm having eyes watering, my doctor has told me not to come into office, and all these things. Any possible reason to stop work. And this is how every single person is, and I am not exaggerating. There are people who there was this guy, we designed that building, just to give you an example. We designed this building and we told them that you have to sit in this particular way. You have to sit in this particular angle so that you will not be you will not be uncomfortable. Like you will not have direct sun falling on you or on your screen, or you will not have issues of glare or discomfort. You will avoid all the issues of headaches and everything if you just turn your desk around. Just turn your chair around by say another 15 degrees and locate your screen this way. we are okay with that. We are quite happy with that. So this is the cost of a typical Infosys building is 2,800 rupees per square feet, and the energy consumption per annum of this is around 55 kilowatt hours. Whereas a typical Indian building of a similar kind will have an energy use of about 140 to 160 kilowatt hours per square feet. So this has been what has been achieved, and water also has gone down by almost more than 50%. But what is important is, again, the cost of an Infosys building, which is fully air conditioned, has the latest technology, is 2,800 rupees compared to the CPWD standard. And this is one of the latest buildings. This is 2013. Even to this day, they have managed to keep their cost like that. And the way that they have achieved this is again through building design. You first look at the building design, the kind of orientation, the kind of design that the building looks, the kind of reducing the heat loads, maximizing usable daylight, ensuring that there is no need for artificial lighting at all for at least 80 to 90% of the year. So that is prerequisite in all design, in all Infosys buildings. Very efficient lighting systems, efficient air conditioning systems, controls, etc. So some of the practices, again, that could help, the passive design practices that they employ or we end up introducing into these buildings end up saving close to 30 to 40% of the energy use straight away, or the cooling energy. The daylighting, because we maximize the use of daylighting, the energy use of daylighting has come down from there to their older buildings had nothing to do with green or sustainability or low energy or high performance at all. They had eggs, glass eggs, to this day where people have to go in with an umbrella or a hat to sit down and work. They are not able to make some of those buildings comfortable. They have glass washing machines at buildings, all kinds of weird, strange shapes and sizes that they have got. And these used to use very high amount of energy. So their lighting load or lighting energy use was about 0.45 watts per square feet, and that has come down to 0.17. So they managed to reduce their energy consumption by 3 times by ensuring that there were lights. There were enough daylight, and they completely avoided the use of blinds. So there are no blinds absolutely installed in any Infosys office whatsoever. So this again is achieved by using different kinds of external shading elements and glazing elements. They managed to achieve without turning on any lights. It's a very well distributed daylight across all towns. So they managed to reduce or get a savings of about 13 lakhs per building per year, just by efficient lighting or maximizing the use of daylight. The next was to look at HVAC systems. So they reduced all the heat loads that were coming into a building. So you have heat. There are several ways that heat enters a building. Am I going too technical? Should I stop being technical? I can skip these slides. So there are different ways that heat enters a building. It enters through the roof, it enters through the glass, it enters through the walls. In an air-conditioned building, it enters through the fresh air that comes into the building. There's also heat generated by people, by equipment and lighting. Right? So this is how these are several ways where these are the heat sources into a building. So when temperatures outside are at 35, we need to keep the indoor temperature at 20. So by very efficient systems or efficient envelope, first thing is we reduce the amount of heat coming into the building through the wall. It is possible to reduce the heat inlet by as much as 5 times. Or 1/5 of the heat only comes in through the wall. 1/13 of the heat that comes in from the roof can be cut down just by using a bit of insulation on it. This is a normal wall. A normal wall will will probably, normal just a plain 200 mm brick wall. It allows about 22 watts of heat to enter from one side to the other side per square meter of wall surface area. Now by going in for a double wall with insulation, you can reduce it by to 1/5 of it or 20% of that, or only for 1 watts. Similarly with the roof, by just going in for insulated roof, you can reduce the heat ingress into the building from 55 watts to 4 watts. So these are just very simple measures that anyone can do. Similarly, there is glass, right? By just a plain glass, just a simple plain glass will cause almost 600 watts of heat to enter per square feet, per square meter of that surface area of glass. Just a single glass. Now by using adequate shading and smart glazing, you can reduce it to about 100 watts. So that is the kind of possibility there is. So about less than about 1/6 of the heat can be reduced by just using proper shading and smart glazing. And most of it actually happens from the proper shading. So if you can introduce shading on a glass wall, it manages to reduce the amount of heat ingress into your room by as much as 80%. So all the various systems that you have got, all these things, look at the passive design, look at the conventional, improving the building envelope, and then improving your lighting design, improving your equipment design to reduce the amount of heat flows and the energy use, make more efficient HVAC systems. All this has helped them reduce their cooling loads by more than, or their chiller capacity, or their HVAC system size by as much as 30%, and their energy use by as much as 50%.
What is HVAC?
HVAC, sorry, it is heating, ventilation and air conditioning, or this cooling system. You can listen at the end. And all this at no additional cost. Now, of course, they had to spend money on that extra double wall. They had to spend money on that special glazing. They, of course, had to spend money on insulating the roof, on very high-end equipment that they use on campus. But they're able to get all that cost back by reducing their system sizing. So, by they're spending 100 rupees more on all these features. Let's say their building costs 100, let's say 1,000 rupees is what a building costs. Now by all this, by using insulated roof, by using double walls, they are using say 100 rupees more on their building, but by using that 100 rupees more, they are able to cut down their system size by about 150 rupees. So they are able to cut down the size of their lighting system, the size of their cooling system. So that's how they manage to keep their costs in check. And of course they are using other kinds of, there are other radiant, something called radiant cooling that I explained to you before about water flowing between walls in old forts. The same kind of technology now, you get them in the form of pipelines. So you can embed these pipes in the roof and have cold water flowing through them, and that is enough to keep the building cool. All you need to supply is a little bit of pressure. So this has helped them achieve close to 66% energy savings. In fact, their Hyderabad campus has, in Pocharam, which is near Gadkesar, they have a building which is absolutely symmetrical. So half of it is conventionally cooled with the most efficient conventionally cooling system, and half of it is through radiant system. It's exactly the same, the usage is exactly the same, everything is exactly the same. The radiant cooling part uses 30% lesser energy than conventional cooling part. And this has been measured and monitored over the last 3 years. And they have consistently seen a 30 to 35% better performance in the radiantly cooled section compared to the conventionally cooled section. And people are very comfortable, actually they are more comfortable in the radiant cooling section compared to conventional cooling. So yeah, I'm not going to go into it. So again, a lot of measuring and monitoring happens. So all this, what has happened is, they're old, so because it's a company which has been building their buildings for probably about 20 years now, Their old buildings used to use as much as 53 units per employee for cooling their buildings. Their new buildings are using only about 18. So that's the amount of efficiencies that they are able to bring about. And not just that, of course, they use a lot of water conservation strategies. In fact, one of the new campuses in Indore that we were involved in, the first design brief from Mr. Narayan Murthy was that we have very, very high person to land person ratio. So, person to land ratio. He's saying that compared to every other country, India has the maximum population and the least amount of land. So the most precious resource, we might find a solution for our energy problems, but where will water come from? So his design brief was to make his campus water neutral, a 140-acre campus, to make it water neutral as much as possible. So that was the first thing he told us, that I want this campus to be made water neutral. So our whole campus design, it was a completely barren land, not a speck of grass on it. We had to develop 30 acres of, 1/3 of it as forested area, and all this by keeping the water balance in check. So it was a very challenging project, but the reason why I'm telling you this is because there is technology available, and there are people who know how to do this. I mean, I'm not the only one who works on these campuses. There are so many other people who work on these campuses to bring about these kind of efficiencies into it. So there is knowledge available and there is technology available to do much better than what we are predicting the buildings to reduce consumption. And then we have, of course, we have a biogas plant to make sure that all their consumption is reduced. Again, there has been a 200% improvement in all their energy efficiencies in their campuses across board. These are the figures that they have achieved. So in 2007, their buildings used to consume 200 to 240 kilowatt hours per square meter per annum. That was their energy consumption in all their buildings. The latest buildings consume 90. In fact, some of these, even the latest buildings that are yet to be built, we are aiming to make that around 60. So that is possible. That is the technology that is available out there to do that. So what has come out of all these things with Infosys is that they are redefining their own standards. So what they are doing is they are putting in all these performance standards into the architect's contract and saying that if you do not achieve these numbers, you lose 25% of your fees. So as a company, as a large multinational, they are able to put in these kind of clauses. They are able to come up with performance benchmarks that they are able to achieve in all their buildings. And that's all they are having to do. They don't have to do anything. Everyone falls in line and everyone starts designing to meet those targets, because they don't want you to lose that 25% of it. Now just imagine if we can do that at a policy level. And that's where, that's what I'm talking about. So it's just a simple benchmarks, and these are the simple benchmarks that can be put into a policy, into regulatory regimes. It can be made regulatory. There is knowledge available, and there is, of course, a lot of technology available, as I said before. But I'm again going to go back and say that policies is very important to achieve this. Right now, most of our energy efficiency policies relating to buildings or water efficiency policies related to buildings are all voluntary. We don't have very strict regulatory indices. We do not have any regulations in our building codes directly relating to our energy use or directly relating to our water use. There's nothing anywhere. There are very, very, very little ones. Whatever strict codes we have are all voluntary. Not a single one of them is mandatory. Now, why is it important to make it mandatory? I'll just give you a German example. They have been working on energy efficiency practices since they have had energy efficiency in their building code since 1980. And in fact, Sweden has been having it since 1950. So, So, what happened because of that is that they managed to improve, they are aiming for, so right now, they are able to, because they started in 1980 with their efficiency policies or mandatory efficiency requirements in all their buildings, at this particular moment they are able to aim for zero carbon buildings. It took them that long to get to zero carbon. But right now, they are aiming for zero carbon residential buildings and all new buildings by 2020 are supposed to be low or zero carbon standards. So that is where they are because they started 30 years ago and they've had a very strict regulatory system in place for so long. And also what happened because of this is, if you look at this particular graph, this is from Germany, energy efficient housing. This was always at 1980, this was what the code allowed them to do. They couldn't go more than this, right? And this was what the technology at that particular time was, the technology that allowed them, that was available at that particular time. I'm sorry, this was the technology that was available. So at that particular time, back in 1980, if the code required only 220 kilowatt hours per square meter per annum, the technology could only achieve about 190 at the most. They could reduce it only by 190 because there was no research into it. People were just building however they wanted. But now because the regime or the efficiency codes have become stricter and stricter, by 1998 or by 2000, even though the regulatory regime asked for only about 120 kilowatt hours per square meter per annum, it was possible to design zero energy buildings. So this was the amount, because of this regulatory index, because of this regulatory regime, the amount of research that went into this market was tremendous. And because of the research that went into the market, they managed to, they are so way ahead of where we are right now. So they are able to achieve all these, they are able to achieve something as low as zero. They have technology to achieve zero energy buildings by 2000. So this is what will happen when you have a strict regulatory regime. It also pushes the industry to improve its performance. So it's not just about all the buildings meeting a certain regulatory index, it's also about more and more research going into it and better technology coming out of this whole system. So in India the present policy is something like this. You know, we have the Energy Conservation Act 2001. The ECBC, that is the Energy Conservation Building Code, was introduced in 2007. But since 2007 to 2014, it is not mandatory. So the last 7 years it hasn't been made mandatory. Only recently, last 6 months, about 4 or 5 months ago, they started making it mandatory, but only for very large buildings. Large buildings with a connected load of more than 600 kV. Star rating of existing buildings was launched, again a very voluntary practice. Ministry of Bureau of Energy Efficiency has empowered ECBC to be mandated in the state, in different states, locally. So any state can take ECBC, they can change it to whatever extent they want, and they can make it mandatory, or they can make it, they can incentivize it in your local, in your local urban bodies. Apart from that, there has been environmental clearance from Ministry of MOEF. There's been, but again, this is mandatory, but it is applicable only for very, very large buildings. It's not applicable for small buildings at all. It's only applicable for buildings more than 20,000 square meters in size. And how many buildings are like that? And of course, Ministry of New and Renewable Energy has introduced the solar buildings program, and they have come up with TERI and Ministry of New and Renewable Energy have launched a national green building rating system called VITA. Again, a voluntary system. So all this national action plan, of course, there's also been the National Action Plan on Climate Change and Mission on Sustainable Habitat. So all this has actually come from that, the National Action Plan on Climate Change. But as you can see, either the mandatory requirements either are related only to very large campuses and very large buildings, or they're all voluntary. So when they are voluntary, nothing much comes out of it. Again, depends on person to person. People who are already doing it will continue doing it. People who don't will not do it. And there are several other voluntary rating systems and guidelines available. So you have the GRIHA rating system, you have the LEED rating system, you have the HMDA environmental building guidelines from the city of Hyderabad, and we have the Pune Eco Homes guidelines. These are more regional, but these are the national level rating systems that are available. Again, all of them are voluntary, all of them are just guidelines, nothing mandatory. Now the only thing that can change what we have, and which has the present technology, we can make this, we can triple this number of 390, we can reduce this even further, we can make it 30-35% by just improving our regulatory index or regime on the buildings, because we have the technology to do it and we have the knowledge. It's just the lack of willpower from everywhere. So how can we do it? So this is what we think should be a way forward. You cannot, of course, say everything has to be mandatory. We can't say that everything should be sticks. There should be some carrots too. So there should be incentives. There should be definitely incentives, but incentives that work. We had conducted close to 30 stakeholder workshops amongst builders and different stakeholder groups coming from the building industry. And we spoke to them what kind of incentives work. And they said that, look, you give us 5 lakh rupees for a green building, it doesn't matter. I mean, what is 5 lakhs for us? But give us quicker clearances. Tell us that if it is an environmentally, if it meets certain targets, we will get our clearance in 30 days. And that's what matters. For us, 5-10 lakhs, all these subsidies really don't matter. So those are the kind of, and they had several other ideas about how incentives could be put in place to promote these things. And those are the kind of incentives one needs to put in. Not, silly incentives like what, political parties do, one fan here, one TV there. Those kind of things really don't work anywhere. Another thing is awareness generation. There is a large gap. So a lot of people think that these sustainable buildings, high performance buildings will cost a lot. So there are numbers, when we go for meetings to new clients, there are numbers ranging from 5% more to 35% more. So people will say, oh, green buildings, sustainable buildings, they must be good. What, they cost about 30% more? And I always have to go back to them and say, no, they will not. In fact, they should not cost you more than what they cost you right now. And they find it very hard to believe because it's a myth. It's a very strong myth that is going around in the industry constantly that these sustainable buildings or high performance buildings are expensive. So that is a myth that needs to be broken, and that can be broken only through proper awareness. So if a building, I will say that as a consultant who's been working in this area for about 15 years now, if a green building costs you even 5% more than what it is, then the building is not being designed properly. Or the benchmarks are not being set properly. Now if this kind of information and awareness can go out into the industry or amongst the public, I think there will be a demand for it a lot more. And once there is demand, I think everyone will fall in place. So that's what is required. This is market dynamics. And then of course, having just incentives and legislation is just not enough. We need to have a very, very, very strong enforcement setup. So what is required would be mandatory compliances and building laws. We need very strong mandatory compliances. And along with those mandatory compliances, we need strong implementation methods. Now when we went through this whole process of developing these guidelines and went back to the government to say that we should introduce this as mandatory practices, not even all of them, but just about 10% of them, they said, and this was their first reaction, they said, we are not even able to implement what we have right now. We want to get rid of what we have right now and make it simpler for implementation. Why do we want to introduce more? So they're not even looking at it from a long-term perspective, they're only looking at it from their implementation or their lack of implementation. So given their requirement, given their issues, I think it's also, it's very difficult to change those mindsets. It's almost impossible to change those mindsets. So we need to find alternative implementation practices. Maybe third-party implementation setups rather than going indirect. And then effective incentives. Effective incentives are actually very, very important. And finally, this is why Florin's right. I would say that this is always something that I always say that we can't solve problems by using the same kind of thinking that we use when we create it. We have to think. And that has to be at every level, be it technology or be it policy. Thank you.